Hi guys, let's look at the next exercise, which is exercise 18b. So before we start the next exercise, let's just revise the new concept that we are doing, which is angle in alternate segment. It says the angle between a tangent and a chord through the point of contact is equal to the angle in the alternate segment. So let's look at this diagram that I have drawn and see how this works for us. So let's say AP is the tangent that we are looking at, and I am looking at the chord QP. So when I am looking at the chord QP and the tangent AP, the angle made between them, in this case, let's say this is angle here X. The angle between the tangent and the chord will be equal to the angle made by the chord in the alternate segment. So the angle made by the chord in the alternate segment is QRP. So this angle here would also be equal to X. Now this is in the alternate segment. I notice that this is in the alternate segment. The angle in the same segment would have been, let's say, something like this. So this is not, so this would have been in the same segment. This is not equal to X. This would be something else. So I repeat, it is in the alternate segment. So if it is coming from the left hand side, then it is in the right hand side. If it is coming from the right hand side, then the angle made by the chord on the other side. So it's in the alternate segment. Good. Let's look at the next diagram. So again, explaining the same concept, let's see how it works if I'm looking at the chord, which is PQ this time. So this is the tangent BP, and the chord that I'm looking at is QP. The angle made between the tangent and the chord, let's say, is Y. Then the angle made by the chord in the alternate segment, in this case, is QRP, and this angle would be Y. So angle BPQ is equal to angle PRQ is equal to Y. So this is the angle in alternate segment. Let's solve some questions. So the first question that we solve is question 3. Question number 1 and question number 2 have been deleted from your syllabus. Not in your syllabus because this year some concepts have been removed. Like I shared in the first video, some parts have been deleted from your syllabus. And for your convenience, I've written all 3 properties that we've done for tangents below, which is tangent makes an angle of 90 degrees with the radius. Both tangents from a point outside the circle are equal, and angle in alternate segment, which is what the third exercise is about. So let's look at question 3. In the following figure, PQ is tangent at A. Okay. O is the center, dB is the diameter. So if dB is the diameter, which means this angle is 90 degrees. Similarly, this angle is 90 degrees. Angle ADB is 30 degrees and angle CBD is 60 degrees. We need to find QAB. Okay. So let's just look at if I can identify an alternate segment. So if I have AQ as my tangent and I have AB as my chord, then the angle made by the chord in the alternate segment, angle made by the chord in the alternate segment would be angle ADB. Yes, so if this is 30 degree, then this angle would also be 30 degree. Angle in alternate segment. So we've got QAB as 30 degree, PAD. Okay, how much would this angle be? So if this is 90, this is 30, then this is 60. Now let's try and identify a second pair of angle in alternate segment. So if PA is my tangent and I look at DA as my chord, then let's see if it is making any other angle in the alternate segment. So the angle it's making in the alternate segment would be ABD. So this is 60 degree. So if this is 60 degree, then this angle is also 60 degree. I could have also found this out as 30 plus 90, 120, which means this is 60. I just wanted to use the property that we've learned now. So angle PAD is 60, CDB. Now this is 90, this is 60, then this angle is 30 degree. Let's just write this down, whatever we did. Number one, AQ is tangent and AB is chord. Like I said last time, writing this is not required. I am writing this for us to understand which tangent, which chord, so that we can identify angle in alternate segment. Therefore, angle QAB would be equal to angle ADB equal to 30 degree. The reason for this, angle in alternate segment. So the first part of the question done. Angle QAB is equal to 30 degree. Next part, PA is tangent and AD is chord, which means angle PAD would be equal to angle ABD. Reason, angle in alternate segment. Let's identify what is angle ABD. Point number 5, angle DAB is equal to 90 degree. Reason, angle in semicircle. Okay. Done, which means in triangle ADB, 90 degree plus 30 degree plus angle ABD is equal to 180 degree. Therefore, angle ABD is equal to 60 degree. So what we have is from 6 and 4, what I get is angle ABD is equal to angle PAD is equal to 60 degree. So the second part of the question also done. We've got this as 30, we've got this as 60. Let's look at angle CDB. Point number 8. Angle BCD is equal to 90 degree. Angle in semicircle. Next, in triangle BCD, 90 degree plus 60 degree plus angle BDC is equal to 180 degree, which means angle BDC is equal to 30 degree. Done. The third part of the question also done. Let's look at the next question. The next question that we do would be question number 4. PQ is tangent at R. Calculate angle PRS. Again, let's try and identify the alternate segment, angle in alternate segment. So if RQ is the tangent and TR is the chord, then let's see if I can identify a angle in alternate segment. Yes, RT makes an angle of RST, which means this angle will be 30 degree. So I have got angle RST. This angle would be 60 degree because angle at center is 2 times angle at circumference. This angle is 90 degree, which means this angle is 60 degree. Let's just write point number 1. RQ is tangent. RT is chord. What this means is angle QRT is equal to angle RST is equal to 30 degree. Reason, angle in alternate segment. Let's see what we can move from here. Next part, it says would be angle ROT is equal to 2 times angle RST. Reason, angle, and this would be equal to 60 degree. So angle at center is equal to 2 into angle at circumference. So this part of the question done. We've got angle ROT as 60 degree. I need to find this angle, remaining angle. So angle SRT is equal to 90 degree, angle in a semicircle. What this means is 30 degree plus 90 degree plus angle PRS is equal to 180 degree, angle on a straight line. What this means is angle PRS is equal to 180 minus 120, that's 60 degree. Done. This part also done. Let's look at the next question. The next question that we do is question number 5. AB is diameter, AC is chord. Oh, so no diagram given. Oh, in fact, diagram is, no diagram given. So AB is diameter. Okay, let's just draw. AB is diameter, AC is a chord of the circle with center O, such that angle BAC is equal to AB produced at D. Okay, center is O. This is A. This is B. AC is a chord. Center is O. BAC is equal to 30 degree. Okay, so this is BAC is equal to 30 degree. Tangent at C intersects AB produced at D. So I am making a tangent at C. It intersects AB produced at D. Okay. Done. So this point is point D. Next, prove that BC is equal to BD. So we need to prove BC and BD are equal. Now this angle obviously is 90 degree, which means this angle is 60 degree, which means this angle is 120 degree. I need to prove that these two angles are equal. If I can do that, then my answer will be done. Again, let's try and identify angle in the alternate segment and see if we can identify the chord and the tangent. So if CD is my tangent and I am looking at BC as my chord, then the angle formed here will be equal to the angle formed by BC in the alternate segment. In this case, will be equal to angle BAC. So if this is 30 degree, then this is 30 degree. This is 120 plus 30, that's 150, which means this is 30 degree. So this is an isosceles triangle, which means BC and BD are equal. Let's just write that down. Number 1, angle ACB is equal to 90 degree, angle in semicircle. Next, angle ABC is equal to 180 degree minus 90 degree plus 30 degree is equal to 60 degree. This is for triangle ABC. This is sum of angle for triangle ABC. Next, number 3, angle CBD is equal to 180 degree minus 60 degree is equal to 120 degree. This is linear pair. Next, angle DCB is equal to angle CAB is equal to 30 degree. This is angle in alternate segment. Here I said earlier we don't need to write which is the chord we are looking at, which is the tangent we are looking at. We just write it for our understanding in the exam, not required. Now that we've done a couple of questions, I don't think we need to write it again and again. Which means in triangle BCD, 120 degree plus 30 degree plus angle BDC is equal to 180 degree, which means angle BDC is equal to 30 degree. Therefore, triangle BCD is isosceles, since angle BCD is equal to angle BDC is equal to 30 degree. Therefore, BC is equal to BD, hence proved. Done. Let's look at the next question. The next question that we do is question number 6. It says tangent at P to the circumcircle of triangle PQR. So there is a circumcircle and there is a triangle. Let's just make the triangle first. Let's make the circle first, and then let's fit in a triangle in here. Yes, so this is my circumcircle of the triangle PQR. So PQR is here, this is P, this is Q, this is R, tangent at P. So let's draw the tangent. This is the tangent at P. If this tangent is parallel to QR, so let's name this, let's say A and B. So this is given parallel to QR. Show that PQR is an isosceles triangle. Done. My diagram is done. Let's see how I can prove this is isosceles. Let's try and identify the angle between the tangent and the chord. So let's look at the tangent PB and let's look at the chord PR. So if the angle between them is X, then the angle in the alternate segment would be the angle formed by chord PR, which in this case would be angle PQR. Yes, so this angle then would be X. If PB is parallel to QR, then this angle and angle PRQ are alternate angle, which means this is X. Therefore, it automatically makes my triangle a isosceles triangle. Let's just write point number 1. PB is tangent. Again, I've gone back to writing this, and PR is chord. What it means is angle BPR is equal to angle PQR, let's say, is equal to X. Reason is angle in alternate segment. Next, since PB is parallel to QR, therefore angle BPR is equal to angle PRQ is equal to X. This is alternate angles. So what we have here is from 2 and 4, what we have is angle PQR is equal to angle PRQ is equal to X. Therefore, triangle PQR is isosceles. Done. That finishes this video for me. I'll see you with the next video with the next set of questions. Till then, take care, be safe, bye bye.